Hello and welcome everybody. Thanks for coming after 2 days of information-packed Magnolia Conference and eventually surviving the conference party. I'm happy to be here and share our findings in a research and development project that has some very promising results that could help in reducing implementation efforts and implementation time, and also to save developers from a lot of hassle. We heard a lot about light development on the conference, and we also had a talk about the holy grail of bringing together front-end and backend, and this is our approach. Just a few words about me. I'm coming from a software engineering and computer science background, and only recently I'm trying to wrap my head around JavaScript and NPM and that stuff. If anybody knows about closures, please tell me after the conference. I'd like to start with a revolution that's been going on for a couple of years now. And, well, that revolution, it's been going on in the front-end world. And that should explicitly mean it did not go on in the back-end world. And the result of that revolution is that if you take pretty much any good website with a responsive design and good user experience, interactive experience, then chances are very high that this was built using a certain tool stack based on NPM and JavaScript. It's pervasive, it's everywhere. Everybody uses it. And everybody develops a front-end prototype because you need that really for responsive websites. Responsive has become a standard. We had a talk about this yesterday. And responsive websites need to be tested, and you gotta try it out on all those devices and turn them to change the orientation and play with it and maybe find out that something doesn't really work well, and then you've got to change it. I mean, testing often and early may mean finding some problem, and then you've got to fix it. And the best way to do this is using a front-end prototype, because as soon as you have your backend implementation with the templates being in the backend, then it's like dragging behind you a big clunky thing or carving in stone your implementation. You're not as agile anymore once you've got the templates in the backend. So that's why everybody is doing the front-end prototype implementation. And well, what has happened technically? That everybody is using this tool stack because everybody's really using the same, more or less the same tool stack. And in the history of things that happened, I think the first notable thing is Chrome V8. Everything we're talking about, it's got to be said, is based on Chrome V8, which was at its time the fastest JavaScript engine on the planet. And what's interesting about V8 is that it was from the beginning designed to be embedded in other applications. And that's precisely what Node.js did. They basically took Chrome V8, slapped it into a command line executable, and provided some API that you can now use from JavaScript to do things like reading and writing files, which of course you cannot do with JavaScript as it is because it was designed for running in the browser. Node.js is a lot of other things, but these are not so relevant here for these front-end prototypes. If just to illustrate it what it means, when you've got Node.js installed on your system, you can write some JavaScript file and then execute it from your command line and use things like this console.log statement, which will output text on the console where you ran it from. Or you could go and type your JavaScript directly into the command line and execute it from there. That's what you see in the last screenshot there. And well, in contrast to Java, it's not, you don't need to compile it first before running it, so that's kind of handy. But things really took off only when NPM appeared, which is the Node Package Manager. And it's comparable to, well, there's an online service which serves a lot of open source modules written in JavaScript and packaged as NPM packages. And it's incredible what amount of modules already exist in there. It's like only now it's already 250,000 modules, and the rate by which this increases is far more steep than with Maven modules. One has to add that some of them are very tiny, as we learned the other day when somebody pulled a package with 3 lines of code in it, and a couple of sites went down afterwards because of continuous deployment. But you could say that anything that anybody on Earth ever needed for building front ends, they put it into NPM, and you can go and use it. It's all open source. So the JavaScript NPM community is very, very active, and still they're constantly churning out new innovations, new tools. This is an example of a colleague from Aperto who wrote a tool that helps you to build front-end prototypes quickly, a bit comparable to something to those tools from Magnolia that can be used from the command line using NPM, only for front-end. So that's all nice and great and interesting, but what's the problem? The problem is that we've got 2 completely separate technology stacks. And you see they don't have anything in common. It's separate processes and separate tools and separate templating languages. And what's interesting about it is that we're so used to it that it's different technologies that it's hard to imagine it could be different. And in particular, the templating language, that it could be used on both technologies. But if you think about it, what's going on in our normal implementation workflow? The front-end developers will go and do their happy coding, and in particular, they invest a lot of effort and time into writing Handlebars templates, which is the templating language which is the most commonly used in the front-end world. So they are writing those templates, then they run their front-end prototype, generate HTML. And what happens then? Something strange is happening. The backend developers will go and take that HTML, cut it into little pieces, copy and paste those pieces into other files, which are pre-marker template files. So there's templating here and there's templating there. And that looks a bit like there's duplicate work going on, and a big deal of duplicate work. And well, if you think about it, that it could be different, that we don't need this duplication of efforts, then it's crazy if you think about it. And to be more precise, it's utterly and totally crazy, because it's so much work, so much time wasted, and it's not fun work. I mean, to translate these little snippets of markup via copy and paste into other templates. At least that's what I think. And what makes it even worse, it's not only duplicate work, it's even work on top of that. Because you've got your 2 different technological structures which are completely independent. And very often you need to propagate changes from one world to the other. Like your front-end developers change something in the CSS and the markup has to be adapted in their Handlebars template. And then the back-end developers have to find out, well, if they change this part in the front-end prototype, where do we have to change it on our side? And Magnolia is already complicated enough. I mean, it's very powerful, but you've got your prototype, what it's called there. You've got template definitions, areas, components, extents, and references, and all that. And sometimes it takes a while to understand which template you need to change now, especially if you didn't look at it for a while. And now if you've got these 2 structures and you need to find the connection between them, it's so many artifacts, like so many template files and structures and relationships and all that. And then it's like juggling with those dishes on sticks, and then you thought, I found it, and then while you think you found it, the others are falling off your brain, and then it wasn't that, it was the other one, and well, it personally, I must say, it makes my brain explode. So this is a 1 day of work, this mad drawing over there, where I tried to understand what the relationship between, I think, only one template was. Well, I had to understand the front end as well, but very complicated. And if you keep that madman's drawing in mind from the previous slide, then it's not a big surprise that there will be bugs during development. So what happens is, I think somebody mentioned it already today, front-end does a change in the CSS and also in their Handlebars template, but somehow back-end didn't get notified of that. And then the bug will pop up in QA and say, guys, something's wrong here, please find out what the problem is. And then a couple of people have to go and look, oh, that's not my problem, it looks fine here, and eventually they will find out there was that change that was not communicated to the back-end developers, we've got to do it now. But what can happen then is that the structures are so incompatible that a seemingly little change in the front end may mean a huge amount of efforts in the back end, or you've got to even refactor both at this point. Because right now it turns out, okay, the way you structured it, simply does not match at all. So, what could we win if we got those Handlebars templates to run within Magnolia, if we don't have that duplicate work? And it's pretty obvious. You've got fewer efforts in development and also in QA and in project management. And I'd say it's substantially fewer efforts. Maybe in a typical project that doesn't have so much back-end logic, in the back-end implementation it could translate to 30+% or something like that. And that also translates to faster time to market. You get much more agile, because in a usual case, it would only be necessary to change the Handlebars template and then commit the code. And then QA will look at the front-end prototype and then look at the continuously deployed Magnolia and say, thumbs up, works. No back-end developer has to touch this at all in the process. That's, of course, much faster. So you can move faster with your changes, be more agile, and maybe try out more things. And also it means a better separation of concerns for developers. As I know, back-end developers, they're not really so keen. I mean, at least many of them are not so keen on doing the templating with FreeMarker, because they have more fun writing Java code. And now they don't need to write any templates anymore, or at least they got to do only a few changes, and I will get back to that later on, what they have to do with the templates, because there is a bit to do, of course, to demarcate where the areas are and the components and stuff. And still the configuration needs to be done, but then with light development, maybe the front-end developers will then start doing that by themselves anyway, because they want to see how the editing then works in the Magnolia, for example. If we step back a little and have a look at the CMS landscape in general, then we realize that this is not a challenge only for Magnolia, of course not. It's a problem for any Java-based CMS, and it's a problem for any CMS that is not based on Node.js, because everybody has to do that copy and paste duplicate work, and with all those problems entailing that. So let's think about for a minute what could happen if in a few years' time there's a great Node.js-based CMS, and any implementation project with that CMS product will take 30% less than any other CMS. What could happen? How will the market decide? So that also, well, it's also for PHP, .NET, whatever you name it, they all got that problem. So, can be interesting to have a look at Handlebars. That's what I thought. So, just a few words on Handlebars itself, because probably backend developers usually don't know much about Handlebars. It's the most commonly used templating language in the front end, and it's actively being developed. And it's got some really great features. And as I see it, there hasn't been so much innovation in FreeMarker, and in Handlebars there's constant innovation going on, and they came up with really good ideas. One of them is the separation between logic and template. We had that discussion with JSPs, where the question was, should we write Java code into the JSPs or not? And in FreeMarker, you often have your variable assignments, many lines of that, and they kind of distort your view of the markup. If you don't have any of this code in your templates, if they are just referencing include files, something like that, or rendering out variables and stuff like that, if you don't have that programming language code in there, even if it is FreeMarker, it's programming language code, then you've got a much better overview of your markup in the template file. I think that's great. It's extensible because you can always write your logic in JavaScript files, which are somehow referenced in the Handlebars templates. And there is a concept of markup inheritance. I'll get into detail about that a bit later, and I think that's also pretty cool because you can really inherit markup from one template to the other and replace some blocks within there with what you want to have in this concrete template. And also, it's performant because Handlebars compiles the Handlebars syntax templates into JavaScript. So in the end, during rendering, it's really JavaScript that gets executed. There is no interpretation of or running through trees or something like that. It's bare JavaScript. So let's have a little look at some Handlebars example. On the left-hand side, you see your Handlebars template. And that's why it's called Handlebars, because you've got these squiggly brackets all over the place. And this is an example of how some variable is being rendered or some data is being rendered through the template. There you see this teaser byline, and this references something in a JSON file. So that's the way how data is provided to the templates in Handlebars. You write it down in JSON files. And JSON files have a hierarchical structure. Maybe that does ring a little bell, because that's already similar to how content is stored in Magnolia. It's a hierarchical database, if you want. One important feature is partials. It's like includes. And partials come with this greater sign over there, and then you provide it with a JSON context. So if you think of that JSON file, it's like a path within that tree, JSON tree, up to a certain point, and this certain subtree becomes the context for the template. And then the template can reference anything within there, within that scope. And you can also pass parameters and remap variables and stuff like that. Let's get to the layout inheritance feature. I'm not sure it's so easy to understand at first view. On the left-hand side, you've got a layout, which is, if you think in Java terms, is like an abstract class. Because within your layout, you define something like, it's a bit like an abstract method. It's a block, and it says, okay, any template that wants to inherit from this layout, it can redefine that block with something else. And that's the page template that inherits from that layout. And then it says, okay, where there is this main block, I want to have this markup. And that's very useful to have all the common markup in a layout, which is common to all your page templates or a set of page templates. As I said earlier, the logic, you can still write it in JavaScript and provide it as so-called helpers. Helpers are very important in Handlebars, and they provide you with some prefabricated logic like control structures or iteration or collection operations and stuff like that. And they often do depend on NPM because they use other NPM modules to provide their functionality. Okay, how to get this to work in Magnolia? And I thought I'd first try to show it to kind of prove that it works. This is a JSON file, and I'll now start up my frontend prototype. You saw that a couple of times during the conference. A few seconds later, there should be my browser popping up and showing me the start page of the frontend prototype. Just give it a second. There we go. Okay. Now I'm going to change something in a JSON file. Now it should reload. Well, yeah, there it is. Oh, believe me, there wasn't this JSON change there before. we could put it somewhere else as well. You see the frontend prototype working in the background? Okay. So we changed the data for the frontend prototype. Now, do I have my Magnolia running? I'm going to look at the same thing in Magnolia. And what I want to demonstrate here is that these are still two separate worlds by the data. The frontend prototype takes the data from the JSON, and Magnolia will take its data from the Magnolia repository. So far, this is pretty common to Magnolia projects. All right, everything as expected. And now let's go for the difference. I've got a Handlebars template here, and this is being used in the teasers. So any change I do here should appear in a couple of teasers. Oh, wait, there it's reloading. Okay, here you see the change. Well, did I take the wrong one? Okay. That was the frontend prototype. And now let's see what happens in Magnolia when I reload the page. There you go. Same template, works both in the frontend prototype and in the running Magnolia. Everybody can do its job. Front-end developers can use the templates, the Handlebars templates to do their front-end templating, and they're running in Magnolia just as well. Let's get to how this is implemented. The basis of the implementation is the Nashorn JavaScript engine coming with Java 8 for a while now, and it made big leaps ahead last year in terms of performance and also in the way that it translates Java objects to JavaScript objects. So Java objects can be used in a kind of natural way in JavaScript. So for example, map objects, you don't need to use the getters there. You don't need to use object.get and then some key, but you can use the key as the object property. You say object.keyname, which is how you want to do it in JavaScript. And it's also necessary for our implementation to work. Then next step to go is use the original Handlebars JavaScript. So because in our first attempt at implementing this, we tried a Java implementation of Handlebars called JKnack, J-K-N-A-C-K. And the problem with that was that the JavaScript helpers sometimes would not work because they rely on a certain Handlebars API, on a Handlebars object, and that Java implementation simply did not provide this API to the JavaScript helpers. And the next step to do is implement the CMS helpers. I think I didn't show any here. Oh, there they are. Okay. So Did I? Or later on. Later on you will see. Well, we have two implementation of these helpers. You saw some helpers early on in the template script. And we introduced something like CMS area only as a handlebars helper. It basically does the same as it does in a free marker. And we've got two implementations. One is in JavaScript, which does basically nothing, then repeating what it contains. It's like a trivial no-op implementation. And in the Magnolia, it'll take the content from the repository and provide that as a JSON context. Of course, it's not JSON anymore, but it provides that as the context. And then very important is a good deal of magical open source portion in order to provide NPM functionality and to support the Node.js API, because all those hundreds of helpers available through NPM, very often they rely on NPM modules and also, of course, on Node.js API. And that was the really non-trivial part of the implementation. Next to those technical challenges, we had some conceptual challenges where everybody said it's impossible to solve. We don't know what to do with this. It's like alien things. It's not the same thing. And the problem was that, well, or something that confused us was that in the front-end prototype, you would find hardwired teasers, for example. So they don't iterate over a JSON structure, but they will pick some of those nodes and copy-paste some markup with different JSON contexts. And that was like, what shall we do with this? Our templates must, of course, be generic. How can we would have to change those templates. It would not be possible to do something like this. But then it turned out that where we have that case, these were usually components within an area. And then we decided, okay, let's just ignore them in Magnolia, because where we have an area, we want to render the components that we have stored in Magnolia. So we just ignore what's within the CMS area in the front-end product. In Magnolia, we ignore what's within the CMS area helper. And in Magnolia, we will instead render the components configured for that area. This example here for a CMS area, it's equivalent to what you saw before. I just could not refrain from turning this hardwired stuff into an iteration, but still it's the same as before. It just looks nicer and less copy and paste. And yeah, okay. What you see within the area is still executed in the front-end prototype. So what does the template script for the area do? There is a default area .hbs file, which looks very much like the FTL equivalent coming with Magnolia. It just iterates over the components and then invokes the CMS component directive and provides it with the iterated component as the current context. This looks really very similar to what you see in FTL. Then the next interesting challenge was, okay, it's great Handlebars is logicless, but where do we put our logic? We need some logic. We've got all those variable assignments in our FTL templates. What shall we do with that? And then we came up with the idea of having a naming convention. When you have a Handlebars template, you can put a JavaScript file right next to it and put your logic in there. We will see that in detail in a minute. And that'll then get executed during rendering before the Handlebars template is being rendered. Then your JavaScript can provide whatever you want to into the context, also invoke Magnolia API or do complicated things. Here's an example. And we can use things like template definition parameters, for example. So at the top somewhere, you see where we use the modulo operator to find an index within an array of colors to determine a changing sequence of colors for teasers, for example. And what you can also see is everything is being assigned to an object called CMS. And this is kind of well, it's a bit like an interface, like an API if you want, because if you have any intermediate variable assignments here, they're not visible to the Handlebars template. The Handlebars template will only see the CMS object. Because I was asking myself when I was looking at FTL code, okay, there's all these variables. Which of these are then really being rendered in the template? Now you can see it immediately. Only when there is an assignment to CMS.something, then this will be used in the template. All the rest you can change, delete, whatever, refactor. You don't have to care, because you know it won't disturb the template. Well, this is one way of providing the logic. You could still use Java models instead, if you prefer that, no problem. And also we noticed that the JavaScript syntax, you don't lose much when compared to FTL. They also have a concept of truthy and falsy. And in FTL, you've got your exclamation marks, and that would be similar to double pipe in JavaScript. And to make this work also outside of Magnolia in the front-end prototype, we came up with the idea of mocking everything that comes from Magnolia in JSON. Only now it is structured along the concepts that we have. At the top you see the CMS object. So we mock here what the result of the JavaScript would be. And you've got def, which is what you probably think if you're a backend developer. It's the template definition. And we mock there what you have in your YAML file in Magnolia. And then there's the actual content with those properties that you have in Magnolia. And of course, it would be quite natural then that to have the same identifiers for properties both in the front-end prototype and within the Magnolia, which will additionally reduce confusion that sometimes exists during development if things are named differently in the front-end prototype and in the Magnolia. Okay, I would like to thank a few people because it wasn't me, just a bit, and most of all Daniel Kazmaroglu for the bulk of the implementation of the open source magical potion, and Sebastian Fitzner, our front-end guru, who created Veeams.org and propagated and advocated the front-end tool stack, and GFT Technologies, who allowed us to use their front-end prototype as the demo for the conference. Okay, thank you.